Since its launch by NASA in 1977, Voyager 1 has been traveling through space for 45 years and has now reached the edge of our solar system. Although this milestone has been anticipated for some time, contrary to scientists' long-standing expectations, the spacecraft has recently made a truly astonishing discovery at the so-called boundary of our solar system, leaving everyone astonished and with more questions than answers. What has Voyager 1 uncovered? Join us as we delve into Voyager 1's remarkable find after 45 years in space. During its voyage into interstellar space, the Voyager probes reached a crucial milestone when they arrived at a region called the heliopause, which marks the boundary separating the solar influence from the vast expanse of interstellar space. It's important to remember that the precise location of this boundary had been a matter of debate for some time. However, thanks to astronomer Bill G.'s predictions in 1993, it was estimated to be between 116 and 177 astronomical units, AU. With each AU being the distance from Earth to the Sun. G's predictions were confirmed when Voyager 1 reached the heliopause about 2 decades later, detecting the anticipated increase in plasma density. Here's where the intriguing puzzle emerged. Despite the rise in plasma density noted by Voyager 1, there was no significant alteration in the surrounding magnetic field direction. This was unexpected because the shift from an area where the magnetic field originated from the Sun to one influenced by other stars should have resulted in a noticeable change. Yet, no such change was observed. Initially, scientists suspected that Voyager 1 might be the problem, but Voyager 2 added another layer of mystery when it also reached the heliopause at similar distances and failed to detect any magnetic field changes. These unanticipated observations present challenges to theoretical models describing the behavior of the heliosphere and its interaction with the interstellar environment. The prediction that there would be synchronization between the heliosphere and the Sun's 11 to 12-year cycle did not match the data obtained from the Voyager probes. Additionally, the solar wind, which fluctuates with the solar cycle, was at its peak strength when Voyager 2 arrived at the heliopause, suggesting that the expected position of the boundary might be farther out than previously believed. Nevertheless, the situation is not entirely disheartening. Thanks to the data collected by the Voyager probes, theoretical models have been revised. Scientists now believe that our Sun has transitioned from a hot, ionized region to a partially ionized phase of the galaxy, possibly triggered by nearby supernovae. These ancient stars heated the surrounding space and stripped electrons from nearby atoms. The boundary between these regions can be likened to a turbulent shoreline characterized by mixed magnetic fields and small-scale variations near the heliopause, while larger-scale changes remain minimal. Regarding the future of the Voyager probes, their paths diverged, with Voyager 1 moving towards the constellation of Aquarius and Voyager 2 heading towards the constellation of Cetus. While some experts predict that the probes may conclude their mission in 2030, they could potentially last for millions of years, outlasting humanity. Perhaps one day, they might encounter other star systems, carrying with them the golden record, a time capsule of human civilization. The Voyagers did not simply journey into space alone. They were launched with missions that were closely connected to humanity's future exploration of the cosmos. After the United States lost the robotic race to the Moon to the Soviet Union in the 1950s, the focus of space exploration shifted. While recovering from the Moon and space dominance efforts, attention turned to a more popular and better-funded manned program. During this period, unmanned exploration took a secondary role, supporting missions like Ranger and Lunar Orbiter, which set the stage for future Apollo missions. The concept of exploring other planets captivated many, coming second only to the excitement surrounding the Apollo missions themselves. Exploration programs naturally shifted towards the next step, exploring other planets. Some argue that robotic missions were more scientifically pure in their design and purpose, minimizing the scientific achievements of manned missions. But it was the prospect of capturing images of the planets that truly resonated with people. The dream began to materialize on September 5, 1977, when an extraordinary spacecraft was launched from Cape Canaveral, Florida, known for its testing of missiles and space probes. This event marked the beginning of a grand journey as Voyager 1 and Voyager 2, twin spacecraft, were sent into space. Voyager 1 was not launched first because just 15 days earlier, its twin, Voyager 2, had embarked on the same cosmic journey. Their mission was to explore Jupiter and Saturn, the gas giants of our solar system, along with their unique moons. No one expected these brave explorers to surpass their initial goals and venture to the farthest reaches of the celestial horizon. The Voyager twins were equipped with cutting-edge technology, even by the standards of their era. From their engines to their propellers and antennas, every component was carefully designed for durability. NASA drew inspiration from the Mariner spacecraft but made some notable modifications. The achievements of these Voyager probes were nothing short of spectacular. Over 40 years ago, their initial observations of Jupiter and Saturn's moons left researchers astonished as their preconceived ideas about these distant worlds were shattered. Previously, it was believed that these alien moons were barren and crater-marked like our own moon, but scientists later found them to be bustling with geological activity. Voyager 2, in particular, achieved several remarkable milestones during its voyage. In 1986, it became the first spacecraft to fly by Uranus. Just 3 years later, it conducted a flyby of Neptune. Voyager 2 remains the only spacecraft to have undertaken such a path to this day. As these resilient spacecraft continue their extraordinary journey, NASA has taken measures to extend their operational lifespans. In recent years, non-essential components and heaters have been turned off to conserve energy for the probes. This strategic action ensures that the Voyagers can continue functioning well into the next decade, with their mission projected to end in 2030. The results of the Voyager missions evoke mixed emotions for the scientists and engineers who have been crucial to this remarkable adventure. Since its inception, their steadfast dedication and relentless efforts have propelled the mission far beyond its initial expectations. The data transmitted by the Voyagers has provided invaluable insights, driven numerous scientific discoveries, and inspired the imaginations of researchers and space enthusiasts across generations. It's worth noting that Voyager 1 and Voyager 2 were not ordinary spacecraft. They were meticulously engineered to be robust systems with a rotation rate more than 15 times slower than the hour hand of a clock. This deliberate design choice minimized any blurring of images and data as the spacecraft sped through space. Even before their encounters with the outer planets, the spacecraft began transmitting images of Jupiter while still several months away from the planet. These early snapshots, showcasing the swirling clouds and the iconic Great Red Spot, brought immense satisfaction to the team at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that stole the show. Io is slightly larger than Earth's moon, but what made it exceptional was its volcanic activity, surpassing any other body in the solar system. The spacecraft detected unusual signals from Io, and the vivid images they captured highlighted these findings. These snapshots revealed towering volcanic plumes on a surface marked by volcanic material ejection. One of Io's prominent volcanoes, Pelée, has erupted 30 times higher than Mount Everest, covering an area nearly as large as France. In total, the Voyager spacecraft captured over 33,000 images of Jupiter and its moons, revealing the planet's stunning beauty and the diverse range of the Jovian moonscapes. Before exploring their latest astonishing discovery, let's remember the twin Voyagers' breathtaking findings since their launch. One of the most spectacular revelations was the discovery of Jupiter's rings, which, though faint, added an extra layer of intrigue to the gas giant. Voyager 2 revealed the icy shell of Europa, one of Jupiter's 53 moons, believed to be over 6 miles thick. These discoveries challenged our previous assumptions about these distant celestial bodies and sparked further investigation into the potential habitability of icy moons. As the Voyagers bid farewell to Jupiter, they received a gravity assist that provided a crucial boost towards Saturn. Without this helpful push, they wouldn't have escaped the sun's gravitational pull and ventured further into space. Voyager 1 and Voyager 2 then set off on separate paths, each heading toward new frontiers. Voyager 1's trajectory brought it close to Saturn's moon Titan. Surrounded by an orange hazy atmosphere, the mysteries of this moon intrigued scientists, leading to further studies on its complex chemistry. Voyager 2, meanwhile, embarked on a series of thrilling adventures that took it to the outermost planets of our cosmic neighborhood. In 1986, it made history with a flyby of Uranus, discovering 10 previously unknown moons, increasing the planet's moon count. 3 years later, Voyager 2 reached Neptune, revealing the extraordinary features of this distant ice giant. During its encounter with Neptune, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, making it the fastest wind ever observed on a planet within our solar system. As the spacecraft approached within 2,180 miles of Neptune's azure methane atmosphere, it provided unprecedented insights into this distant world. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar system. The discoveries made by the Voyager probes have transformed our understanding of the outer planets and their moons, opening new avenues for exploration and igniting excitement for future missions. Moving beyond Jupiter, the Voyagers traveled towards Saturn, where they uncovered the complex ring system and the diverse moons orbiting the planet. Voyager 1 provided detailed images of Saturn's largest moon, Titan, revealing its dense, nitrogen-rich atmosphere and hydrocarbon lakes. Voyager 2 continued its journey towards Uranus and Neptune, becoming the first spacecraft to fly by these distant ice giants. The mission to Uranus revealed previously unknown moons and unusual magnetic field interactions, while the encounter with Neptune provided insights into its dynamic atmosphere and its moon Triton, known for its nitrogen geysers. Perhaps the most significant achievement of the Voyager missions was their entry into interstellar space. Voyager 1 accomplished this historic feat in 2012, becoming the first human-made object to reach the space between the stars. Voyager 2 followed in 2018, further expanding our understanding of the heliosphere and the boundary where our sun's influence wanes against the backdrop of the Milky Way galaxy. The data transmitted by the Voyager probes continues to shape our knowledge of the heliosphere, interstellar medium, and cosmic radiation environment. Their observations have challenged existing theories, provided new insights into planetary atmospheres, and prompted further exploration into the potential habitability of distant moons. Beyond their scientific contributions, the Voyager missions have inspired generations with their resilience, curiosity, and spirit of exploration. The golden record aboard both spacecraft encapsulates the diversity and creativity of human civilization, serving as a message to any extraterrestrial intelligence that might encounter the probes in the distant future. Looking ahead, the Voyagers continue their quiet journey through the vastness of space, carrying with them humanity's hopes and aspirations for discovery. As they traverse the darkness between the stars, their instruments remain operational, sending back valuable data that will guide future missions and deepen our understanding of the universe. In conclusion, the Voyager missions stand as a testament to human ingenuity, perseverance, and the relentless pursuit of knowledge. They have not only broadened our cosmic perspective, but also reminded us of the limitless possibilities awaiting us in the uncharted realms of space. As we celebrate their accomplishments, we eagerly anticipate the next frontier of space exploration, where new spacecraft will build upon the legacy of the Voyagers and continue to push the boundaries of human exploration further into the cosmos.